Somewhere in the heart of Antarctica, beneath 2.5 miles of solid ice, lies a secret that defies everything we thought we knew about our planet. A body of water the size of Lake Ontario, 12,500 square kilometers of liquid water, has been locked away in complete darkness for up to 25 million years. This is Lake Vostok, the largest subglacial lake on Earth. And until recently, it was entirely beyond our reach. Here at Vostok Station, Russian scientists endure conditions that test the limits of human endurance. The lowest temperature ever recorded on Earth was measured right here, -89 degrees Celsius. Cold enough to shatter steel, cold enough to freeze your breath in midair. Yet for over a century, scientists have suspected that something impossible lay hidden beneath this frozen wasteland. Something that shouldn't exist. Liquid water. In the coldest place on the planet. The story begins in the 1890s, when Russian scientist Peter Kropotkin first proposed a radical idea, that massive freshwater lakes might exist beneath Antarctica's ice sheets. At the time, it seemed absurd. How could liquid water survive under kilometers of ice in the coldest environment on Earth? Decades later, Russian geographer Andrei Kapitsa would put Kropotkin's theory to the test. During Soviet Antarctic expeditions between 1959 and 1964, Kapitsa and his team conducted seismic soundings near the newly established Vostok station. They sent sound waves deep into the ice, listening for the echoes that would reveal what lay beneath. The results were puzzling. The seismic data suggested something unexpected, a boundary that reflected sound differently than rock or ice. Kapitsa suspected it was water. But the technology of the era couldn't confirm it, and his data was filed away, nearly forgotten. In a twist worthy of fiction, Kapitsa's precious seismic records survived a devastating fire, stored in a simple garden shed. Those charred but intact datasheets would prove invaluable decades later. In the 1970s, British scientists conducting airborne ice-penetrating radar surveys detected unusual readings over the same region. Something was definitely down there. But the final confirmation would require technology that didn't yet exist. That technology arrived in 1993, when remote sensing specialist J.P. Ridley analyzed data from the European Space Agency's Eros-1 satellite. Using laser altimetry, Ridley detected subtle surface features, flat areas on the ice sheet that suggested the presence of liquid water below. Lake Vostok was real. And it was enormous. The numbers are staggering. Lake Vostok stretches 250 kilometers long and 50 kilometers wide. Its waters reach depths of up to 900 meters. Buried beneath nearly 4 kilometers of ice, the lake sits 500 meters below sea level in complete, eternal darkness. The pressure at the lake's surface exceeds 350 atmospheres, more than 3 times the pressure in the deepest parts of the Mariana Trench. And yet, despite temperatures hovering around -3 degrees Celsius, the water remains liquid. This impossible liquid state is maintained by 2 factors: the immense pressure from the ice above, and geothermal heat rising from Earth's interior. The lake is literally being melted from below while being sealed from above. Lake Vostok has been sealed off from the rest of Earth's biosphere for 15 to 25 million years. To put that in perspective, when this lake was last connected to the surface world, horses were the size of collies, and the Himalayas were still rising. The ice above Lake Vostok contains a continuous climate record stretching back 400,000 years. But the lake itself is an even more precious time capsule, a window into a world that existed before humans walked the Earth. Reaching Lake Vostok would become one of the most ambitious drilling projects in human history. Russian scientists began their quest in the 1970s, not even knowing for certain that the lake existed. They would continue for over 2 decades. The challenge was immense. How do you drill through nearly 4 kilometers of ice without contaminating a pristine ecosystem that has been isolated for millions of years? The solution was as ingenious as it was controversial. The Russians used a mechanical drilling method, filling the borehole with a mixture of kerosene and freon to prevent it from collapsing under the immense pressure. For 30 years, this toxic cocktail sat in the hole, just meters from the lake's surface. Environmental groups and some scientists raised alarms. What if the drilling fluid leaked into the lake? What if the lake's pristine environment was forever compromised by human intrusion? Some advocated for hot water drilling as a cleaner alternative, but the Russians pressed on with their method. The drilling continued through the decades, stopping just short of breakthrough in the late 1990s when international pressure demanded a pause to assess contamination risks. The lake waited, undisturbed, as the world debated. Finally, on February 5, 2012, at 8:25 p.m. Moscow time, after more than 2 decades of drilling, the Russian team broke through the last few meters of ice. The drill penetrated into liquid water. Pressure from the lake forced water up the borehole, creating a frozen plug that sealed the hole. They had done it. After 20 years of drilling in the most hostile environment on Earth, Lake Vostok had been breached. A year later, in January 2013, the team extracted their first sample, ice that had frozen from actual lake water rising into the borehole. The first material from Lake Vostok was finally in human hands. The question on everyone's mind: was there life in Lake Vostok? After millions of years of isolation in complete darkness under crushing pressure, with no sunlight to drive photosynthesis, could anything possibly survive? The answer, remarkably, was yes. Analysis of accretion ice lake water that had frozen onto the bottom of the ice sheet revealed over 3,500 different DNA sequences. This was no sterile environment. Lake Vostok harbored a diverse microbial ecosystem. The organisms found were unlike anything in surface environments. Bacteria such as Brachybacteria, Methylobacterium, Paenibacillus, and Sphingomonas, species adapted to extreme cold, high pressure, and total darkness. Some were thermophilic, suggesting geothermal activity at the lake's bottom. 2 species of archaea were identified, ancient microorganisms representing a completely different domain of life. Most incredibly, these microbes had evolved to survive without sunlight. Instead of photosynthesis, they practiced chemosynthesis, deriving energy directly from minerals, essentially eating rocks to survive. They had transformed the lake's geology into biological energy. Some of the organisms found were similar to bacteria, typically found in the digestive systems of fish and crustaceans, raising tantalizing questions about whether more complex life forms might exist in the lake's depths. If microbes could survive here, what else might be possible? In 2013, Russian scientist Sergei Bulat announced an even more startling discovery: a bacterial life form with less than 86% DNA similarity to any known organism on Earth. If confirmed, this would represent a completely new branch of the tree of life, evolutionary cousins so distant that they challenged our understanding of biology itself. The claim was controversial. Some scientists argued the unusual bacteria might be contamination from the drilling fluid or surface equipment. The debate raged in scientific journals and conferences. In 2017, reports confirmed that water samples were indeed heavily contaminated with drilling fluid, making analysis of truly pristine lake water impossible. Yet even with contamination concerns, the evidence for indigenous life was compelling. The diversity of organisms, their extreme adaptations, and their consistency with an isolated evolutionary history all pointed to one conclusion: Lake Vostok was alive. But Lake Vostok is more than just a scientific curiosity. It may be the key to answering one of humanity's oldest questions: are we alone in the universe? Jupiter's moon Europa is one of the most promising locations for extraterrestrial life in our solar system. Beneath its icy crust lies a vast liquid water ocean, potentially containing more water than all of Earth's oceans combined. Like Lake Vostok, it's cold, dark, and isolated. As NASA JPL Deputy Chief Scientist Kevin Hand stated, when it comes to Europa, there's no better analog on Earth than Lake Vostok. The parallels are striking. Both have thick ice crusts over liquid water, both experience extreme cold and crushing pressure, both have been isolated for millions or billions of years, and both may harbor life forms that have evolved completely independently of surface ecosystems. NASA's Europa Clipper mission, planned for the 2030s, will study Europa's ice shell and subsurface ocean. The technologies and protocols being developed are directly informed by Lake Vostok research. Before we search for life on Europa, we're learning how to find it in Earth's own alien world. The lessons extend to Enceladus, Saturn's geologically active moon where geysers of water ice erupt from cracks in the surface, suggesting a subsurface ocean that, like Lake Vostok, might just harbor life in the darkness. Lake Vostok reminds us that our planet still holds secrets, vast, profound secrets that challenge our assumptions about where life can exist and how it can survive. In the most hostile environment on Earth, in complete darkness, under crushing pressure, separated from the surface world for 25 million years, life found a way. As we look to the stars, searching for life beyond Earth, Lake Vostok stands as both a lesson and a promise. If life can survive here in this frozen alien world beneath the ice, then perhaps the universe is more alive than we ever dared to imagine. The drilling continues. The research goes on, and somewhere beneath 2.5 miles of Antarctic ice, Lake Vostok keeps its secrets, waiting for us to return and to learn.